And I think it's hilarious, right? Like NVIDIA, some truck, $10-20 million worth of NVIDIA wafers are driving to Miaoli.
It doesn't sound like a big deal, but in the chip business, it's marginal gains. It's marginal gains every step of the way.
They're tearing them out, they're repackaging them, and they're shipping them to Europe.
Welcome to Supply Chain. I'm Tim Colpin from Colpium.
And I'm John from Asianometry.
John, TSMC has trucks.
Oh,
What's with that?
really? They do. I didn't know that.
You did one of my favorite videos is one you did recently on TSMC and trucks. Okay, to be fair, it's not actually about TSMC and trucks, but I would not have thought that would be a feature of TSMC's business model. So why does TSMC have trucks?
You know, it's kind of an interesting thing. I knew for a while, it's been this idea, this thing that I've known for a while, it's stuck in my head, is that, when, a couple months ago, I don't know if you remember, but before memory became this big thing, everyone thought TSMC was the limiter
Yes.
on the AI boom, right?
Yes. It was chip blocking everyone.
Yeah, it was chip blocking everyone, and we're not going to have anything, and because, TSMC underinvested early on, like
They were
when
lazy.
ChatGPT came out, TSMC should have went from $40 billion of 35 billion to like 150 capex, and that's their failure. And now all these other companies are going to take over.
I can't get my cat videos because of TSMC.
That's right. Your AI to cat videos. And now, though, I think everyone's now watching Chinese AI dramas.
Yes.
Which are worse. Absolutely terrible.
But TSMC solved the problem by buying trucks.
It wasn't quite like it's kind of like an interesting thing because it's like demand meets supply. So the way it works is that one of the things that we know that TSMC has a problem is that their fabs get, there's a stranded fab problem as customers move from node to node, right?
Right.
So in your wonderful podcasts for Odd Lots, you talked about one of the big struggles of TSMC is that finding leading edge customers is hard. There's not that many anymore. So if Apple goes from 7 nanometer to 5 and then from 5 to 3, then they've just left this. If TSMC doesn't just upgrade the fab from 5 to 3, then there's this big hole they got to fill.
Well, let's just pause there and note one thing about the TSMC model that I think a lot of people are not clear on is that when TSMC goes to a new node, they build a whole new fab.
Right.
So TSMC's early fabs with lower numbers, they're now up to 22 fabs or something. The lower numbers will be the older fabs.
Yeah.
And they go on to a new node. They just build a whole new fab.
Right.
They don't re-kit out the old fab. They just, all right, I'll buy a new one.
That's the general impression.
Generally, that's the general business model that's been going for 30 years.
Yeah. And I think Ben Thompson talked about it. And I think a lot of people said, like, oh, it's a cash flow, throws up a lot of cash because then those are depreciated equipment and all that, right? And then in recent years, though, it hasn't been quite true.
They've had to renovate that model a little.
They have to change the model a little bit. So I think like the main thing is that when when Apple moves from 7 to 5 to 3, what happens is that companies start losing you have to fill the fab. Otherwise, the fab is going to lose money. If the fab doesn't hit 60-70% utilization,
Right.
It starts burning cash just as fast as it earns it.
Yeah.
So N7 right after COVID, because post-COVID, it was dropped to I think Dylan said it was like 40-50% utilization. It was pretty bad. The company must have been losing hundreds of millions of dollars at the very least, which doesn't sound like a lot now, but it was
a lot.
It's a lot. And I think, and because that was a risk. But meanwhile, when AI started ramping up in 23 and 24, then now you have the opposite problem on the other side. You have this problem where there's not enough N3 or N5 capacity. So in order to understand how they fix this or how they ameliorated it, is that you have to understand all chips, all nodes are basically very similar. There's maybe hundreds of layers, and then, but maybe you would say some percentage, just think of a percentage are the same. Like anything above maybe the transistor layer, like these big metal layers where you have these big interconnects, pretty similar.
So a chip basically is built like lasagna. It's layer upon layer upon layer,
I was
right?
gonna say it's a tiramisu, but yes, yeah.
Lasagna
I
or
like tiramisu.
milfie. Yeah,
Oh, milfy.
milfie. So it's layer upon layer upon layer. You start obviously at the bottom layer,
Right.
theoretically. You do a layer, you finish that off, metal layer, interconnect, all that. Go up to the next layer, transistors,
Right.
and so forth. But one thing I got from your video is not every layer has to be the same node.
Mm-hmm.
You could have on a lower layer, say 7 nan,
Right.
and on a higher layer, theoretically 28 nan or something else.
Correct.
And that is great for TSMC and the customers because
Right.
it means you don't have to have everything on the expensive layer.
Right.
You can mix and match.
Right. So one of the things they started is something they called, they put it in the earnings report too. In the earnings transcripts, they start talking about cross-node utilization.
Yes.
And so it started out first with 5 and 3 because 5 and 3, fortunately, are in the same fab, Fab 18 in Tainan, which is a monstrously huge fab. I've never seen anything so large in my life.
I think of it as the Apple fab.
It's
not quite, but it is kind of. Yeah.
Is now the NVIDIA fab, my friend.
Right.
And so that's like a majestic fab. And because N5 and N3 those lines are next to each other, it's easier to do the cross node utilization because they're right next to each other.
Yeah.
But then now 5 is full too.
Right.
5 is full, 3 is full, N2 is weird, no one needs it yet. So the only thing left
Except
is like
Apple, yeah.
is an N7, right?
Right.
So what are you going to do? How are you going to But then N7's all the way in Taichung. Tainan, N3 and 5 are in Tainan.
Tainan and Taichung are what, 100 miles from each other?
100
Less,
miles as the
about
crow
50
flies.
miles. About,
yeah, 100 as the crow flies. But
right.
So how are you going to fix that? Trucks. So I was told that basically that they were already doing this for packaging, right? You have to think about the packaging fabs are nowhere near the regular fabs, right? Like and I think it's hilarious, right? Like NVIDIA, some little truck with NVIDIA wafers, $10-20 million worth of NVIDIA wafers are driving to Jai or something, Miaoli, but this time they repurposed that to do half of the wafer, some portion of the wafers are done in Tainan, and they ship in a truck and they drive them up
the highway. There is 2 or 3 great highways between, like, basically along the whole coast of Taiwan, I should point out.
Right.
It's a pretty easy drive.
It's a fairly easy drive, but like just imagine, right? Like the sheer size and the logistics of it, where you basically have to like truck all these wafers to get them done.
I think TSMC should just rent out a high-speed rail carriage twice a day to take it up the highway.
Yeah, they should. I mean, they might build their own little high-speed rail that goes underground to take them from Tainan to
a long-distance wafer shuttle.
I know. So I was asked. So when I heard about this, I asked. I was like, have you seen these trucks? What do they look like? And the guy was just like, it's just a truck. It's just a truck.
I'm thinking some like super duper cool, hip, like EV truck, futuristic, because it's TSMC.
Yeah.
Not really.
No, it's just the regular. And then when I finally got the picture, because I think my friend was like, look, I'll take a photo for you next time I see it.
So your friend's hunting on the highway for a TSMC truck.
He must have been driving somewhere, and then he saw it, and then he says, there it is. And I took a photo, and it's the ugliest thing I've ever seen. It's just a regular truck. It's like that time the British wanted to send the Cullinan diamond from South Africa to Britain. They put it in a box and just mailed it. So like, it's exactly it.
How do you know it's a TSMC truck?
If you look very closely, there's a logo, and the pelican has a little wafer, or the animal or the logo. The guy has a little. Sometimes a pelican, sometimes a thing.
Because there is a courier company in Taiwan, Pelican. It has a pelican as its logo. Yeah.
Yeah, and but they would have a little wafer modification.
That's cute.
So and then if you hang around the fabs, which I don't always, but like as you do, you'll see these trucks puttering in and out. Like they're constant. So you'll see trucks coming in, bringing in, materials and raw goods and stuff. But then you also see these little. They look like 7-Eleven supply trucks.
That is so cool.
It is amazing, isn't it?
Yeah, but it does kind of get to the point of how, first of all, TSMC has to be innovative, right? I mean, it's just the way. But the other thing is, it reminds us of the fact that this cross-node utilization is really an ingrained part of the TSMC business model now. And another part of cross-node utilization, apart from doing different nodes at different layers of the same chip, is the fact that there is some overlapping between tools from node to node.
Right.
It's not like you're bringing in a whole new set of tools for every node. You don't go from 7 to 5 and like never use the same tool again. But there is going to be some new tools because you're scaling down or more of a certain tool. Famously, when you go from, say, 28 to 16 to 10 to 7, we're bringing in EUV, which is, a different set of litho tools. But it means that the engineers who are familiar with these tools can be utilized for the new nodes. So there's that cross-node utilization, and TSMC is always looking for the next node. What tools do we use now that we can reuse?
Yep.
It's kind of like switching between Boeing and Airbus. Like a pilot who can fly an Airbus can't fly a Boeing, they've got to go and get re-rated. So you want to keep consistency amongst your fleet. Similar concept to TSMC. And it doesn't sound like a big deal, but in the chip business, it's marginal gains. It's marginal gains every step of the way. If you can reuse a tool, that's a few $1,000,000, dozens of millions of dollars that can be reused, and ramp up is quicker, training is quicker, metrology is quicker, all of these things are quicker just by being able to utilize cross-node utilization.
You want to hear my favorite utilization?
Yes.
Reutilization of a tool?
Tell me.
When TSMC, TSMC is building a fab in Germany, right?
Right.
We all sort of
Dresden.
forget ESMC. Do you know where the tools are coming from?
I have no idea.
They're coming from Taiwan.
Really?
Yeah, they're taking the tools that are in older and like in regular or maybe a medium-sized fab. They're tearing them out, they're repackaging them, and they're shipping them to Europe.
Wow.
Probably
that's interesting because I remember a few years ago, CC Wei did say that they were literally going to change the node of some fabs, which was a new thing, which I talked about. They normally don't do that. They're retooling fabs for new nodes. So the old tools,
they gotta go somewhere.
Going to Dresden.
They're going to Dresden. Yeah, I was talking to some people, and they're saying this is their current job, and I didn't expect it something they need to do. They didn't expect it either.
A semiconductor tool packager.
Yeah, they're taking it out. They're good at, like, a lot of them are familiar with install, right? They're not so familiar with relocation.
Yeah, uninstall is difficult.
Yeah. They're taking this stuff and shipping it, and it's a lot of new stuff that they're doing right now. And I think that's sort of the TSMC's mastery here, that they use every part of the cow.
Yes, I was just thinking the same.
So which
is awful. Yeah.
It's totally ruthless, and I think that's what makes them so difficult to outcompete.
Yeah. Wow, that's a great place to leave it. I really recommend people go and check out that video because it's really one of my favorite Asianometry videos recently. What was the title of it?
How TSMC uses old fabs to make new chips.
Great. And the subtitle should be TSMC has trucks. You've been listening to Supply Chain. I'm Tim Colpin from Colpium.
And I'm Jon from Asianometry.
Thanks for listening.